Good afternoon, ladies and gentlemen. Without due honors, good to have you here today. We're missing a couple of our valued class members, if such they can be called. Jay and Gabby. But we'll just get through somehow. That's what we do. So in problems 11 through 14, find the product or quotient as indicated and list any excluded values. What's going to be a problem-solving strategy on this one? What would be the first thing you look at trying to do on this one?
Try to make it a multiplication.
Pardon me?
Make it a multiplication.
Okay, try to make it a multiplication. So that's like a conceptual thing. So we can do that right now. How do we make that a multiplication?
Flip the last one.
Yeah, so what we're going to have is we know that it's going to be x. If we change this like that, times 3x minus 12 over x. Okay? So that's one thing. What else can we do on this? Somebody said factor. Who said factor?
I think it's Julia.
Was it you?
Was it Kim or Julia?
It was Kim. Okay, it was Kim. So yeah, that's a good thing. 3x, and that's what Victoria said, 7th period, as a first step. Good advice. So we have 3x minus 4. Is that it? Okay, what next? Rewrite. So we have here x plus 2 over x minus 4, and we've changed that to a multiplication one. So we have 3, and that's x minus 4 here over x. Okay, what can we do now? Combine them, right? So we can like this. And what cancels out? X minus 4, x minus 4. So what do we have left? 3x plus 2 over x. What else?
Excluded values.
Exclude values. So I had, that was a suggestion of Kim or Addie or Julia, I don't know who it was.
It's taken.
There it goes. Cannot equal 4.
So x cannot equal 4. Anything else?
You literally told me the answer. 0.
X cannot equal 0. And one thing you can do for this is you can test excluded values, because I'm not sure if I entered this one in the calculator. Did I enter this one? No, I didn't. But, oh well. Yeah, you can test by graphing. So this would be our answer here. And that's it. Questions on that one? No? Okay. Next, 13. What would you do on 13? Factor, right? That's what I would do. 2x minus 4. What's that going to be equal to? 2 parentheses x minus 2. Everybody good with that? And then we have x squared minus 9. What's that going to be? X plus 3, x minus 3. Any excluded values headed our way? So x cannot equal negative 2. And x cannot equal plus or minus 3. Anything else? Now, some people, like somebody in 7th period, mentioned 2 would be the excluded value, but is 2 okay here?
Yeah, because it's not, we didn't flip it.
Yeah, we didn't flip it, denominator can be 0. But, I mean, numerator, excuse me, take back what I just said, numerator can be 0. Denominator cannot be 0, right? So these are excluded values. And so now if we write this out, oops. I'll get it right somehow. So we get x plus 3 over x plus 2 times 2, x minus 2 over x plus 3, x minus 3. What is that going to be? What do we do with that?
You can
Cancel, X plus 3.
X plus 3. So we have left 2, x minus 2 over
We didn't write it.
x plus 2, x minus 3. Okay, are we okay on those? Yeah.
Mr. G,
Yes.
could you factor out the negative sign out of x minus 2? Make it x plus 2? And then cross off the x plus 2?
Okay, Ben has, as usual, a really good idea. And somebody tried to do that, I think second period, but we figured out we couldn't do it.
It's not the same.
Yeah, and why can't we do that? But that's a good idea, to look for a further opportunity for simplification.
Oh, if you back up, then x would be, then it would be negative x.
Yeah, yeah. And so what happens is, the thing you look for is on the top, on the numerator, those signs of x and 2 are opposite each other, right? If we had on the bottom, like 2 minus x, for instance, then we would be able to do what you're suggesting. But I'm really glad that you thought of doing it, because if you could have done it, that would have been an opportunity for further simplification, right? So that's some good work. I'm trying to remember who had that good idea second period too, but it's worth a look. Thank you for thinking about it. Okay, go look at 14 and work on 14 for a minute, and we'll go over that in another couple minutes. Okay, I'm gonna write some things here. I've got, as far as factoring, x squared minus 16 is going to be equal to x plus 4, x minus 4, right? And so really that's our only factoring. So excluded values x cannot equal plus or minus 4. Any other excluded values?
2.
2, right? X cannot equal 2. And so really, that's, I think 0 is okay, isn't it? Because I'm not seeing any X by itself here. So I think we're okay, right? And then next thing we can do is what Mark has suggested, right? We can take and change this into what? X plus 4, X minus 4. Over X minus 2. And what opportunities for cancellation do we have?
X minus 4.
Is that right? And we've worked out a lot of problems where there have been more opportunities for cancellation. We don't really see a lot of them here.
4 and 0.
Is that as far as we can go on this one? I think. Yeah, I think it is. And trying to see what I had on the calculator here. No, I didn't have any of these. Okay. Let's go on to number 15. At number 15, like all these problems in the review, I really took from the actual test and just kind of changed things up a little bit. And they said solve the rational equation by completing the table and graphing the results. Well, what's wrong with this problem? There's something that's wrong with it.
Well, there's nothing to solve.
Yeah, Ben said there's nothing to solve. To have an equation, you need an equal sign, right? So what we're going to have is the equation is going to be this. 0 equals this. Okay, that's going to be our equation we're going to solve. And basically what this was originally, it would have been, because we did these exercises, 2x minus 4 is equal to 1. How do you solve this? Well, if you subtract 1 from both sides, you get this. Okay, so that's what we're going to do. So let's go ahead and I'm going to give myself a little skinnier pen. So now we're going to just one at a time do this. I'm going to go through this pretty fast. If we plug in 0, we're going to get 0 minus 1 or negative 1. So our coordinate pair here is going to be 0, comma, negative 1, which is going to be right here. Okay? And then we can continue. If we plug in 1, we get 1. Let me write it up here to give myself a... We have 1 over 2 minus 4, which is going to be 1 over negative 2 minus 1. So we get negative 1/2 minus 1. So this would be negative 1.5. So we have 0, negative 1.5. Next, if we plug in 1.5,
0.
we get 1.5 over 2 times 1.5, which is 3 minus 4. So we get negative 1 minus 1. So that's going to be negative 2.5 minus 1, or negative 2.5. So this is going to be 1.5, comma, negative 2.5.
Do you have them both as opposed to yet?
This one here?
No, the middle one.
This one here?
The X, Y.
Oh, thank you. Julia caught me. Thank you, Julia. Yeah, this should be an input of value. Thank you, Julia. All right, yeah. So we want this to be as correct as possible. Thank you. Okay, next, if we take 2.5, we get 2.5 over 2.5 times 2 minus 1, so that's going to be 2.5 over 1 minus 1. So 2.5 minus 1 is 1.5. So here we get 2.5, comma 1.5. And next, if we plug in 3, we get 3 over 2 times 3, which is 6. 6 minus 4 is going to be 2. So we get 3 halves minus 1. That's going to be 1 half, or we'll say 0.5, right? Or 0.5. So here we get 3, comma 0.5, we'll say. The last one, if we take 6, 6 over 2 times 6 is 2 times, that's 12 minus 4, so it'll be 6 over 8 minus 1. So that'd be 3/4 minus 1 is going to be negative 1/4, or negative 0.25. So that's going to be 6, comma negative 0.25. So now we're really left to graphing this. What's going to be our excluded value for this equation? What can x not equal? So x cannot equal 2, Ben says. Let's go ahead and make sure that's right. We can't divide by 0. Cannot equal 0. So that would be 2 times x minus 2 cannot equal 0. So therefore, yeah, x cannot equal 2. So we can just draw in a vertical asymptote. So I'm going to say vertical asymptote is going to be x is equal to 2. That's our vertical asymptote. Okay, next, we can plot our points and sketch out the graph. We've already plotted this point here. So we got 0, 1, and we have 1, negative 1.5. So that's going to go about right here. And then the last one we have on this side of the asymptotes, we have 1.5, negative 2.5. So here's 1.5, negative 2.5. So this curve will be drawn in something like this. I don't like the way that's drawn here. Let's try it again. Man, that is really not very good looking. That asymptote looks pretty good there. Something like that. And then over here on the other side, we have 2.5, 1.5. So there's 2.5, 1.5 right here. We have 3.5. So 3.5 is going to go right here. And we have 6, negative 0.25, like this. So we have something like this. What is going to be our solution here? X is equal to what? What's our solution? X is equal to, where does the graph touch or cross the x-axis? Where does the graph touch her? Does the thing touch or cross the x-axis here? No. Where does the graph touch or cross the x-axis? Looks like 3.5. Let's take a look at the calculator. So here's the thing in the calculator right here, right? I'm going to activate it. Go down here. And so now we should graph in the calculator where it is. Where does the graph touch or cross the x-axis? 4. So this is going to be x is equal to 4. That's not an excluded value, right? 2 is the excluded value. So that's going to be our answer to number 15. Another thing you can do is look at the table view. See that you have where x equals 4 where y equals 0. Okay, next. This last portion here is solve each rational equations algebraically, list any excluded values. So what do we need to do to solve rational equations? We need to have what? A what? A least common denominator. So let's go ahead and mark it. Addie says least common denominator. What's our least common denominator here? X plus 1, x plus 4. Any excluded values? Yeah, so for this one we have x cannot equal -4, comma, -1, which is in set notation, meaning that's not a coordinate pair, right? Okay, what do we do to solve this? Multiply the numerator by the least common denominator. So here we have x plus 1, x plus 4, and that's on the left side. On the right side we have 2 over x plus 4. And then same thing, right, Addie? And what happens now? If we've done this right, what's going to happen? We'll have all our denominators canceled out. Do we have all our denominators canceled? Yeah, we do. So we have here now, we get 5 times x plus 4 on the left. On the right side we have 2 times x plus 1. So that's going to be 5x plus 20 is equal to 2x plus 2. Okay, what next? Solve for x. So we'll subtract 2x here, subtract 2x here, subtract 20 here, subtract 20 here. So we get 3x equals -18. So x equals -6. Or do we have any excluded values here? Is that an excluded value? No, it's not. So this will be answered. Real solution. Okay, exclude values. So I want you to go ahead and look at number 17. Well, I think I graphed this in the calculator too. You can solve by graphing. I think I put it over here. Yeah, let me show you here. I did this in an earlier class today. So you take this one right here and solve for 0 by subtracting one side from the other. You graph, and you can see that we have a solution here at x equals -1, -2, -3, -4, x equals -6, right? Is that our answer for that one? Yeah, she said. Yeah, x equals -6. Okay, 17, go ahead and do that. X equals -6, that's right. Go ahead and do that one. We will go over here in a couple minutes. We got the fan blowing in here a little today. I think it helps. Okay, at 17, any factoring to be done? No. But do we have, what's going to be our LCD here? Or at least common denominator? Okay, x plus 1 is going to be part of it. What else? 2x. So now, if we multiply by the least common denominator, I think that's correct, we'll be able to go ahead and cancel out everything in every denominator, right? And then do we have any excluded values here? Okay, Addie says 0 and -1. So I'm going to go with that, say x cannot equal -1 or 0, right? Everybody okay with that? Okay, good. All right, let's go ahead and multiply through by our least common denominator. 3x times 2x, x plus 1. That's a double parentheses on the right. Okay, and that's going to be over x plus 1. And then we have plus 6 over 2x, and that's multiplied by 2x, x plus 1, right? And then finally on the right side of the equation we have 7 times 2x, x plus 1. 7 times 2x, x plus 1. And that's going to be over x. Do all of the denominators cancel out? Yeah, that'll cancel out. And 2x will cancel out, and x will. And what do we have left? 3x times 2x. And we have plus 6 times x plus 1. And that's going to be equal to 14 x plus 1. What next? Distribute. Distribute property. So we got 6x squared plus 6x plus 6 equals 14x plus 14. Okay, what next? Now the last problem we did, we had a linear equation. What kind of equation do we have here? We have a quadratic equation. And so does our problem-solving strategy change comparing a linear to a quadratic equation? Yeah, it does. Now remember our linear equation, where we're getting the variables on one side, the numbers on the other side. What do we do for quadratic equations? Yeah, set it equals 0, right? So we move everything over to one side. Now if you just have a square root type equation like we did in that SAT problem today, where you had b squared equals 12, right? You don't want to subtract 12, you want to just take the square root of both. Well, no, we had b squared equals 144, that's what it was. So b equals 12. So here, how do we get everything to one side? We subtract 14x minus 14. So we have here minus 14x minus 14. And so we have left 6x squared minus 8x minus 8. And that's going to be equal to 0. Okay, so we got 6x squared minus 8x minus 8 equals 0. What's going to be next problem solving thing going on here? What can we do? Any ideas? We can factor. What's our factoring going to be for this? Yeah, 2. So we have 2 times 3x squared minus 4x minus 4. Equals 0. What can we do now? I'm going to bring this up over here. Okay, what you can do is you can divide by 2. What happens when you divide by 2? Yeah, so on the right side we have 0, and so we can take if we can factor this out here, what is going to be the factored form of 3x squared minus 4x minus 4? Can you use the x method for this?
Yes.
You really can. You can. Okay. But the factors, so I'll do that right up here. I don't have a lot of room. But here we have negative 12. And down here we have negative 4. So what two numbers multiply together and get negative 12 but add together are negative 4, or the difference equals negative 4?
6, negative 6.
So negative 6 and 2, right? And then if we divide by A, and A is 3, right? So we get 3. On the left side we get negative 2. So we're going to get x minus 2. And over here we're going to get, like, if we have x plus 2/3, what is that going to be bottoms up? That's going to be 3x plus 2, right? Is that going to work for negative 4x? Yeah, that's going to be right. So x is going to be equal to what? 2, and x is going to be equal to negative 2/3. Now, today so far, all the solutions we found have been integer solutions, right? But in this case, it's not. So that's one thing you got to watch out for. Are any of these excluded values? So not excluded values. I'll just read not excluded values. Not excluded values. Real solutions, right? Okay? Next. Problem 18. What's our least common denominator? X minus 8. What's our excluded values? X cannot equal 8. So here we have x over x minus 8 times x minus 8. And up here we have 2 times 12 minus x over x minus 8 times x minus 8. What happens here?
Nothing.
Cancels out. Cancels out. So we get x equals 24 minus 2x. So we get, as we add, we get 3x is equal to 24. So x is equal to what? X is equal to 8. Is that a value? It cannot be right. So this is extraneous solution. So there we are at the end of class, and end of the review here, so work hard. If you need to review, you can watch this video, or we have the QR code of the video for everything, right?
Oh, yeah. I got this tomorrow, right?
What's that?
I got this tomorrow.
Yeah, tomorrow. All right, thanks.